lesson on discrete mathematics. I'm going to be talking or introducing the idea of algorithms. And I want to just introduce simply with a game. So if I'm given this array or this numbered list of items, and I want you to pick a number that I'm thinking of. So we're going to play the guessing game. And the rules are guess a number 1 to 10 that I'm thinking of, and then I'll tell you higher or lower. Now, I've already played this with some of my students, so we can simulate what happens. So I've asked the student to think about what number I'm thinking of, and they wisely choose 5, halfway in between. And I tell them, nope, it's not 5, it must be higher. So if it's not 5, and it must be higher, I can eliminate all of these possibilities. And then I ask the student again, what's the number that I'm thinking of? And they now know its range is 6 to 10. So again, cleverly they decide I'll choose 8, and I say, nope, lower. So get rid of 8, everything higher than that. And now they've really got their choice of each of these numbers. Usually the student gets it at this point, and guesses 7, which is correct. If they had guessed 6, I could have marked that off, and they would have got 7 in the 4th guess. Okay? So usually students solve this within 3 or 4 guesses, and the worst case, as I had mentioned, if they choose 6, would have been 4 guesses total. Now what I've actually demonstrated here, and if you've been playing along with the guessing game, is logarithmic, let me spell this out properly, logarithmic complexity. Okay? So with logarithmic complexity, the idea is we can get rid of half of the choices each guess. Okay? And that'll tell us how many guesses we have. So log base 2, or in binary, the number of guesses, or the number of choices we have here, will give us guesses in the worst case. Okay, so how long do we have to play this guessing game? So you can imagine if n is very large, let's say n is 1,000, how many guesses would it take? Well, I'm going to do a simple calculation here, and log base 2 of 1,000 is, one moment while my calculator follows up, is about 9.96, but we can't actually really use this number well. 9.96 guesses doesn't make sense. So it's actually the ceiling, which means we always round up, even if this was 9.1, so 10 guesses. Okay, so that seems much better than if we had 1 through 1,000 starting out at number 1 guessing, number 2, 3, 4, and so on. Okay, so we can actually do pretty good with this this logarithmic complexity. It saves us a lot of time. And often with computers, we're interested in saving time and searching for information as fast as possible. And we can do this again because these numbers are in order, so we can eliminate half the possibilities at each guess. That's what's known as logarithmic